Testing, 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 testing. Okay, so taking a moment to document some of the coil work that we've done here. Talk a little bit about Starship coil. This is what I would consider to be a one-turn coil. Okay, it's one layer thick, hence one turn, one complete turn around the former. This coil is a three-turn coil, similarly. Okay, and it like the former coil here, is made with 22 and 12 gauge bifilar windings. This is a 4-turn that's been compressed. Okay, and it is 16 gauge and 22 gauge. 22 and 26. That's 8 turns. And then this is a few more turns than this. Actually, that one's 6. This is 8. This was the first coil I wound for this with a little smaller wire, and I found that it got a little hot, melted down the former there. So I went to a heavier gauge, and it wasn't ringing at the frequency that I liked. The fundamental was a little bit too low. So then I went to the one that's on the machine now, which you'll see in a minute. These were the high current test models, as well as this one. This is a 2-turn on a smaller former with 16 gauge and 22 gauge. And there's the final former design. Allows for convective cooling, which is really all that's necessary if it's allowed and tuned properly. Okie dokie, Boo Boo and Smokey. We're going to go through some of the latest revisions to the carbon cracker here. I've been doing a lot of tweaking and tuning, and seems to be producing pretty well. And I've found some interesting things to happen. Okay, so next. Here's our primary circuit that we're using. That's the GeneSiC 1200 volt transistor, and a couple of Fuji Electric diodes. We got the big fatty 50 watt rheostat here, and then we got scrap graphite on both terminals, positive and negative. You'll notice that I separated the electrical connection from the mounting connection there. That provides a little more stability. We're getting significant ultrafine particle production this way. Then we're operating this guy at a little better than 25 kilohertz. There's some interesting effects there. Okay, so that circuit is driving this big fatty coil here. This is 2 full Starship turns on this former, and then on top of it there's a degaussing coil with an LED as a status indicator. Next we have the exciting circuit. It's not really that exciting. It's a simple Bedini with 2 variable resistors there, 2500 ohm and a 500 ohm. Using a tip 35, and we have this smaller 4-turn coil here. This gapping here, that's important to eliminate feedback from one coil to another, because that makes kind of a dirty sine wave, or a dirty wave rather, as opposed to a clean peak. Presently we're running this off of the Variac here, which has been dual fan cooled to be up to the duty. We're consuming 396 watts from the wall now. And our production's pretty good because of it. Let's take a look at the waveform for a second. Okay, I want you to see this ring down here. This is the very beginning of the ring form where almost 600 volts to the good and 100 volts to the bad. But this ring down that happens over the space here of, you know, about 3.5, 4 microseconds is pretty interesting. If you actually go in and count the peaks and troughs there, ignoring the changes in amplitude and whatnot, you get to about a 5 megahertz frequency for the ring down. So whatever it's ringing, it's donging it, and it's ringing back down at about 5 megahertz. So I dare say that if we tag this joker with 5 megahertz to start with, we might have some interesting results. But I'll let you see the general waveform here. And we're right at the moment, we're at about 25.3 kilohertz, and that is actually, believe it or not, I can make the big coil ring at the first subharmonic of the primary of the exciting coil. The exciting coil, here's its scope trace over here, and it's at 76.2 kilohertz, 76 kilohertz, somewhere around there. It fluctuates up and down. So we're at a fifth right now, believe it or not. This big coil is being excited at a musical fifth in relationship to the frequency of the little coil. It's ringing at 77, and this is ringing at 25 and change. Sorry, 76. The bottom one is ringing at, and 75.33, 25.33 or so is what the big guy's ringing at. Now I can change the base resistance here on the current limiting resistor, and I can sneak that up to the first subharmonic, so like 37 kilohertz. But my waveform starts to get funky at that point, and I'm not quite sure how safe that is for the FET. We do get an awful lot of heat, so I kind of back it off. You can see the little particles floating around in there. Maybe we can get a good focus, I don't know. We'll try. You can see them dancing in and out. There are some really tiny particles. And of course we have the gas production going on there. So that's where we're at. This one's producing pretty well, but I still don't probably think at the rate that the other device is at. But it's probably for sure better than 1/3 the rate, which it's using 1/3 the power. So I still think we're at a win there. We may have to scale up the switching a little bit to allow a little bit more power to pass through that coil, or be able to increase the voltage anyway. We'll see how that works out. Graphite felt in between with hemp in between there. could be a very interesting little battery type of setup. Okay, that's it for now, guys. Thank you. Okay, look. Let me direct this, okay?